The rest of Unit 3 is about conic sections. A conic section is a curve obtained from a cone surface intersecting a plane. The general equation for conics is ax squared plus cy squared plus dx plus ey plus f equals 0. For a circle, a is equal to c and both are not equal to 0. For an ellipse, a is not equal to c and ac is greater than 0. For a parabola, either a equals 0 or c equals 0, but not both. For a hyperbola, a times c is less than 0. Circles. A circle is the set of points in a plane that lie a fixed distance, called the radius, from any point, called the center. The diameter is the length of a line segment passing through the center whose endpoints are on the circle. In addition, a circle can be formed by the intersection of a cone and a plane that is perpendicular to the axis of the cone. Remember, the equation of a circle centered at the origin comes from the Pythagorean theorem, x squared plus y squared equals r squared. So if we shift the center horizontally by h and vertically by k, the center will now be at hk. If we draw a right triangle from the center to a point xy on the circle, the base of the triangle will be x minus h and the height will be y minus k. This makes the standard form equation of a circle x minus h quantity squared plus y minus k quantity squared equals r squared. Number 1, graph the circle. H is equal to -1 and y is equal to 3 and r squared is 9. So the center is at -1, 3 and the radius is 3. Graph the center and then graph 4 points. 1 3 units above the circle, 1 3 units to the right, 1 3 units down, and 1 3 units to the left. And complete the circle. Number 2, rewrite the general conic form equation in standard form. Then graph. The coefficient of x squared, a, is equal to 1. The coefficient of y squared, c, is equal to 1. Since a is equal to c, this equation represents a circle. To write the standard form of the equation, we need to complete the square for the x's and complete the square for the y's. Bring the constant over to the right side by adding 11. Now group your x terms and your y terms, leaving space for your c values. To complete the square for the x trinomial, take -4, divide by 2, and square it. Add that number, 4, to both sides of the equation. Do the same for the y's. Divide -2 by 2 and square it, adding 1 to both sides. Factor the x trinomial and the y trinomial. Now you have the equation in standard form. X minus 2 quantity squared plus y minus 1 quantity squared equals 16. This means the center is at 2, 1, and the radius is 4. Now graph your circle. Pause the video and repeat the process from Part A for Part B. And you end up with a circle whose center is at -4, 3, and radius is 3. Ellipses. An ellipse is the set of points in a plane whose distance from two fixed points, called foci, have a sum that is equal to a positive constant. In other words, if points f1 and f2 are the foci, that would be plural of focus, and d is some given positive constant, then xy is a point on the ellipse if d is equal to d1 plus d2, as pictured at right. Deriving the equation of an ellipse. To obtain the simplest equation for an ellipse, we place the foci on the x-axis. At f1 would be -c, 0, and f2 would be c0, so that the origin is halfway between them. For later convenience, we let the sum of the distances from a point on the ellipse to the foci be 2a. Then if the point xy is any point on the ellipse, we have the sum of the distance from the point to f1 and the distance from the point to f2 equal to 2a. Use the distance formula to algebraically represent these distances. To solve an equation with two radicals and another term, we must make sure the radicals are on opposite sides of the equation. Now square both sides and expand. Bring the remaining radical to one side and the other terms to the opposite side and square both sides again. Expand and bring all x and y terms to the left side and the other terms to the right side. Since the sum of the distances from P to the foci must be larger than the distance between the foci, we have that 2a is greater than 2c, or a is greater than c. Thus, a squared minus c squared is greater than 0. And we can divide each side of the preceding equation by a squared times a squared minus c squared. Remember that in this case, a and c are constants, they're not variables, so it's okay for us to divide both sides by any constant. For convenience, let b squared equal a squared minus c squared, with b greater than 0. Since b squared is less than a squared, it follows that b is less than a. This makes the standard form equation for an ellipse x squared over a squared plus y squared over b squared equals 1. Because a squared minus c squared equals b squared and a squared is greater than b squared, in the standard equation for an ellipse, a squared is the larger denominator and b squared is the smaller denominator. If the larger denominator a squared is the denominator of x squared, then you will have a horizontal ellipse. If the larger denominator a squared is the denominator of y squared, then you will have a vertical ellipse. The graph of each of the following equations is an ellipse with center at the origin and having the given properties. The vertices and foci lie on the major axis. For number 3, find the foci, the vertices, and the lengths of the major and minor axes, and sketch the graph. Because 9 is greater than 4, a squared is 9 and b squared is 4, making a 3 and b 2. Because a squared is the denominator of x squared, we have a horizontal ellipse, meaning the vertices, foci, and major axis all lie on the x-axis, since the center is at the origin. The vertices come from A, and since they are on the x-axis, they will be at plus or minus 3, 0. The major axis length is 2a, so 6. The minor axis is 2b, which is 4. To find the foci, solve for c in the equation c squared equals a squared minus b squared. So c is ± √5. To graph the ellipse, plot the vertices. Now use the length of the minor axis perpendicular to the major axis to graph what are called the co-vertices, points on the ellipse and the minor axis. Those would be at 0 plus or minus 2. Now plot the foci and complete the ellipse. For part B, a squared, the larger denominator, is 16 and b squared is 9. That means that a is 4 and b is 3. Because a squared is the denominator for y squared, we have a vertical ellipse, and the major axis, vertices, and foci lie on the y-axis, since the center is at the origin. That means the vertices are at 0 plus or minus 4 on the y-axis. Fill in the major and minor axes and solve for c to find the foci. Now graph the vertices and co-vertices. Since the minor axis is 6, the co-vertices are at plus or minus 3, 0. Plot the foci and complete the ellipse. For number 4, rewrite the general conic equation in standard form. Then find the foci, the vertices, and the lengths of the major and minor axes and sketch the graph. 4x squared plus y squared minus 40 equals 0. A is equal to 4 and c is equal to 1. Since a does not equal c and 4 times 1 is greater than 0, this equation represents an ellipse. Begin by bringing the constant to the right side of the equation. The standard form equation is equal to 1, so divide both sides by 40. X squared over 10 plus y squared over 40 equals 1. This means that a squared is 40 and b squared is 10. Since a squared is the denominator of y squared, this is a vertical ellipse, where the vertices, foci, and major axis lie on the y-axis. Pause the video and find the following to graph the ellipse. Write in simplest radical form. Because 10 is slightly bigger than 9 and the square root of 9 is 3, that would be about 3.1 or 3.2. Multiply by 2, and 2 root 10 is approximately 6.3. 30 is about halfway between 25 and 36, so square root of 30 is approximately 5.5. Graph the vertices, co-vertices, and foci to complete the ellipse. Conic sections, conic sections, conic sections, circles and ellipses.